Okay, now that we've been working with factoring for a little while, we're ready to get into some quadratics in a deeper way. We're going to be looking at the different forms quadratics can come in. And remember, quadratics have an x squared somewhere in there, but they don't have to all look the same. We're going to look at three main forms, and then there's some other junk. The first main form is called general form. Sometimes people call it standard form. So I'm going to write out the general equation. The general equation is y equals ax squared plus bx plus c. And we can see that that is a quadratic because it's got an x squared in it. An example would be like y equals 3x squared plus 6x. Notice that there's no plus number here. It's okay for c to be 0, or even for b to be 0. But, you know, it's still in general form. So what does general form tell us? Well, the A tells us whether it's vertically stretched or compressed, just like before. So vertical stretch. And let's remember that that's if A is bigger than 1. Or compress. I guess I should say the absolute value of A, because it doesn't matter whether it's negative or positive. The absolute value of A is less than 1. The A also tells you if it's reflected, and that's if A is negative. So A is less than 0. And then the other thing it tells you, and this is special to this, is the C tells you the y-intercept. Whatever number is being added on here is the y-intercept. It will be 0, c, because when you plug in 0 for x, 0 plus c gives you c. And so we can see in our example that it's vertically stretched by a factor of 3. It is not reflected, so it'll be concave up just like the parent function, and the y-intercept is 0. We also can do the quadratic formula, which is the only form we can do it in, and we'll be talking about the quadratic formula in a few more lessons. So we can do the quadratic formula only when it's in general form. What are some situations that this comes up in? Well, in physics, which is about how the world works, a lot of very physical qualities are related to this. For instance, the A is gravity, and on Earth, that will always be like negative 32, I guess in this case it would be negative 16 feet per second squared. On the moon, it would be a lower number. The B is about the starting speed or starting velocity. And we'll talk about that more later. And of course, C is the y-intercept. It's the starting height. We'll talk some more about that another day. Vertex form is a different way quadratics come up. And we've already done this. Sometimes it's called vertex form. Sometimes it's called transformation form. And this is y equals A times x minus h squared plus k. And this is called an example of this would be y equals negative x plus 2 squared plus 5. And this is called vertex form because it tells you the vertex. It also tells you the same A things from before. So that A is actually the same letter in both. And if we change from one form to another, the exact same A will be in this equation. And so it will also tell you the stretch, compress, and if it's reflected. Additionally, it tells you the vertex. And this is because this is a transformation of the parent function, y equals x squared, where it got shifted h units to the right and k units up. So the vertex will be hk. And remember, this is backwards from what you might think. The h is backwards from what you might think. So shifts left and right are backwards from what you might think. This is very useful for graphing. This is good for graphing. Okay? The next form we're going to look at is factored form. And factored form is going to be when we have y equals A times x minus x1 times x minus x2 when it's factored. An example would be y equals x plus 3 times x minus 4. This is factored form because we've got a quadratic where two things are multiplying times each other. And in addition to the A telling you the stretch, compress, reflection, just like all the other forms, that same A will tell you the same things. X1 and X2 are the x-intercepts. So that's where on a graph the x value, where the quadratic crosses the x-axis. So for this one, the reason it's x minus 1 and x minus 2 is it's backwards. It's what x value will make it 0. And here 4 will make the y value 0. And negative 3 will make the y value 0 because negative 3 plus 3 is 0. 4 minus 4 would be 0. And so it has, its x-intercepts are a little bit backwards from what you might think they would be because it's what x value will make the y 0. And it tells you where the x-intercepts are. That will also tell us that the vertex is always halfway in between the x-intercepts. And so we'll talk later today about how to find the vertex if you know the x-intercepts. Okay, there are some other junk forms. For instance, if you had like x minus 3 times x plus 4, but then plus 7, this doesn't tell you anything. It doesn't tell you the y-intercept or the vertex or the x-intercepts, but if you were to multiply it out, you could get it into one of the other forms. It tells you nothing until you get it in a different form. So these different forms tell us different things. Like this one does not tell us the vertex, but this one does. This one doesn't tell us the x-intercepts, but this one does. Neither one of these tells us the y-intercept, but this one does. And so what we want to be able to do is change back and forth between the forms, and that's what we're going to look at in just a minute. And we're going to talk about how we can use these forms to our advantage. And you'll be able to see by the end of the day how to change a junk form into something we might be able to use. So let's talk about changing from vertex to general form. Vertex, of course, test yourself now. Which of these is vertex form? And hopefully you know that vertex form is a times x minus h squared plus k. And we're going to change it to general form. Which one is general form? Well, that's y equals ax squared plus bx plus c. Now, why might we want to change from vertex to general form? Well, I guess the question becomes like, well, what is general form good for that vertex form is not good for? And I can think of two pretty good reasons. Maybe we want to find the y-intercept, because this one tells us the y-intercept. This doesn't. It tells us, you know, where the vertex is, but the y-intercept, where it crosses the y-axis, it doesn't tell us directly. And so maybe we want to change it to this form so we can tell the y-intercept. More often, what we might want to be doing is using the quadratic formula, which we'll talk about in a few classes, but you can only use it in this form, and so we might want to change it to be able to use it. We might also want to factor. So you can't go directly from here to factoring, but you can go from here to factoring. So let's look at this. How do we change from vertex form, from general form to vertex form? And I hope what we see here is this vertex form means that we're doing 2 times x minus 3 squared, and then we add 1. Now the order of operations, PEMDAS, says that we do exponents before we do multiplying. So we've got this exponent, and we have to do it before we multiply. We are not allowed to distribute. This 2 cannot distribute here. That would be incorrect. And the reason it's incorrect is because it has to be squared first. So let's talk about how to square a binomial. So if you have x minus 3 squared, we want to evaluate this. We're going to do x minus 3 squared first, then we're going to multiply it by 2, and then we're going to add 1. But let's talk about a shortcut for squaring a binomial. Squaring binomial shortcut. And so x minus 3 squared, squared does not distribute. Squaring does not distribute in a binomial. What squaring means is multiplying times itself. This means x minus 3 times x minus 3. And when we have a binomial times a binomial, the first term distributes to both of the others in the binomial, and it gives us x times x is x squared. X times negative 3 is negative 3x. And then this one distributes, and we get negative 3 times x is negative 3x, and negative 3 times negative 3 is positive 9. Oops, sorry. I had to get rid of a remind message there so I could see how much time this was taking. And last, we can combine these and get x squared minus 6x plus 9. But you are going to square like, I don't know, 500 binomials, and you don't want it to take this long. This takes like 30 seconds. You don't want to spend 30 seconds 500 times. That's crazy. That's like 4 hours of squaring binomials. So instead of doing that, we're going to learn a shortcut. And to see how this shortcut works, what we're going to do is we're going to do a plus b squared. We're just going to put variables in to see what will always happen. When we have a plus b squared, it will always mean a plus b times a plus b. And when we multiply it out, a will always distribute. A times a will be a squared. A times b will be ab. And we saw that above. We saw x times x was x squared. X times negative 3 was negative 3x. ab means this one times this one. Plus, now the b is going to distribute. B times a. B times a is ba, but we also can switch it around to be ab. And b times b is going to be b squared. And just like we saw up above, these middle ones will always combine. AB plus AB is 2 ABs. And so this is our shortcut. You can go straight to saying, look, when you have a plus b squared, it doesn't distribute. You might think it would just be a squared plus b squared, but you would be missing this middle part. So the shortcut is you square the first one. You multiply these two together. That's what a times b means. You multiply them together and multiply that answer by 2. And then lastly, you square the last one. So let's see how that works with the one we just had. X minus 3 squared. We square the first one. We multiply these two together. So x times negative 3 is negative 3x. But then we have to multiply it by 2. So these multiply together. So negative 3 times x, and then multiply that times 2. So negative 6x. You multiply these two together and then double it. And then you square the last one. Negative 3 times negative 3 is positive 9. This will always come out positive. Whether it's a negative squared or a positive squared, it'll always come out positive. Let's have you try some of these. What about x plus 5 squared? Try it on your own. Well, it's x squared plus we square the first one. Then we multiply these two together and double it. So x times 5 is 5x. Doubled is 10x. And then we square the last one. 5 squared is 25. 5 times 5 is 25. Try it again. X plus 10 squared. Well, we square the first one. Then we multiply these two together and double it. X times 10 is 10x. Doubled is 20x. And then we square the last one, 100. Last one to try. Let's do x minus 7 squared. We square the first one. We multiply these two together. That's negative 7x. And double it. It's negative 14x. And then we square it. Negative times a negative always gives us a positive. And that's how we square a binomial. So we're going to be using this today. And you have to know this. Like, it's useful right now. We actually have to know the shortcut in a few classes. So let's look at how that applies here. Now that we know the squaring binomial shortcut, we always square the binomial first. And then we're going to multiply, and then we're going to add. So we're going to bring down the 2 and bring down the 1. And we're going to write, instead of 2 times x minus 3 squared, it's going to be 2 times whatever x minus 3 squared is. So what is x minus 3 squared? Well, we square the first one. We multiply these two together and double it. And then we square the last one. And then we got the plus 1 there. Next, we can't add yet because PEMDAS says we need to multiply first. This is 2 multiplying times this trinomial, and so it will distribute. So we get 2x squared minus 12x. 2 times negative 6x is negative 12x, and 2 times 9 is 18, and that plus 1 is still there. Last, we can add the 1 with whatever is there, and we now have it in general form. ax squared plus bx plus c. We can tell that the y-intercept, so the information we already had we used to know from the very beginning, we used to know the vertex was 3, 1. This is 3 to the right and 1 up. That's what vertex form tells us. We also know, because of this 2, it is vertically stretched. And we know it's going to be concave up also because it was not reflected. So we know a lot. We could graph this already. But our new information that we have is going to be, we also know the y-intercept now. We didn't know the y-intercept from this one, but now we do. The y-intercept is always when x is 0, what is the y? And it'll be this constant left over, because 2 times 0 is 0, negative 12 times 0 is 0, 0 minus 0 plus 19 is 19. So when x is 0, y is 0. Why don't you guys try this on your own? So get in general form. Try this one on your own. And hopefully the first thing you notice is that you need to square the binomial. So we're going to leave the 3 alone. We're not going to multiply yet. We always have to square the binomial. And the way we square a binomial is we square the first one, multiply these two together and double it. So x times 5 is 5x, doubled is 10x, and then we square the last one. We can't subtract the 3 yet. The next step, after we square it, we're doing PEMDAS, we square it first. Now we multiply. So y equals 3 times x squared is 3x squared. 3 times 10x is 30x. 3 times 25 is 75. And now we can combine these like terms and subtract. So y equals 3x squared plus 30x plus 72. Hopefully you feel okay about that. What about this last question? What is the y-intercept? So this is in general form. We've completed what the prompt was. What is the y-intercept? Is the y-intercept 3? No, it is not. This is not the y-intercept. This is the vertex. The vertex is over at 4, 3. That isn't the y-intercept. The y-intercept is, where is it going to cross the y-axis? It's going to be like somewhere down here, I think. I can tell it's going to be down there because I can tell it's concave down. And so it's going to be like, I don't know, down there somewhere. Okay, so to get the y-intercept, let's change it into vertex, into general form. Go ahead and do that on your own, and then say what the y-intercept is. Well, what do we need to do? Well, first we square this. So f of x equals -2, we're going to leave it alone, times whatever this is, and we're going to leave the plus 3 alone. So what is x minus 4 squared equal to? What happens when we do x minus 4 times x minus 4? We know our shortcut is to square the first term, then multiply these two together. That's -4x's, double it, which is -8x's, and then square the last one. -4 times -4 is +16. Next, we need to multiply. After we do exponents, then we multiply. The 2 will distribute. This is -2x squared. A negative times a negative is +16x's. -2 times +16 is -32. And the plus 3 just comes down. We can combine these like terms. Get -2x squared plus 16x minus 29. And as I said, the y-intercept then is going to be down here somewhere. Where is the y-intercept? It's a point 0, -29. When x is 0, y is -29. I want to show you a shortcut that can find you the y-intercept. If all you need to do is find the y-intercept, the y-intercept is when x is 0. When x is 0, that's like right here. You need to find what the y is. So in this case, the point was 0, -29. So it's f of 0 is -29. Well, if all you need is the y-intercept, you don't actually have to convert it all the way into standard form or general form. You can do it directly by just doing f of 0. The y-intercept is 0, whatever the y is there. And so you can put in 0 from the beginning. I'm going to take this and put in 0 for x. So it said -2x minus 4 squared. F of 0 means we put in 0 for x. 0 minus 4 is -4. -4 squared, we have to do PEMDAS, we square it before we multiply. -4 squared, -4 times -4 is +16. -2 times +16 is -32. And negative 32 plus 3 is negative 29. And so you can, just by plugging in 0 into the beginning, it's a little annoying. You can't see it quite as easily as you can in general form, but you can still plug in 0 to find the y-intercept by putting in 0 for x. Okay, last thing we're going to look at today is general form to factored form. So which one is general form? Hopefully we know general form is ax squared plus bx plus c. Which one is factored form? Factored form is when we factor. We've got a times x minus x1 times x minus x2. And why might we want to do this? Well, there's a few reasons we might want to get into factored form. Factored form tells us the x-intercepts. And on a graph, what the x-intercepts represent is like where something is hitting the ground a lot. Like if something goes up in the air, we learned earlier this year that quadratics often represent things that are flying in the air. Well, a lot of times we want to know, where do they hit the ground? Like certainly like if the military is shooting a missile, they want to know where the missile is going to land. So find where something like hits the ground or lands. How long something is in the air for. We can tell how long something is in the air by finding the x-intercept. We can also use the x-intercepts to graph. It's not quite as good as knowing the vertex form, but we can do it, and we'll see how in a second. So here's our example. How do we go from general form to factored form? Well, we are going to factor. All we're going to do is factor. Now, we need to leave the y equals, but you should already know how to factor, and so go ahead and factor this. I hope you noticed that they all have a common multiple. We always look for a GCF first. It's the first thing we do when we're factoring. They all have a 2, and so you needed to factor out the 2. 2 times what gives you 2x squared? Well, 2 times x squared. 2 times 3x gives you 6x. And 2 times what gives us negative 8? 2 times negative 4 gives us negative 8. This is partially factored. We can do even more. We can split this part apart. So we're going to bring down the 2. And this is just a equals 1. So we're looking for what multiplies to make negative 4. That adds to be 3. And the ways to multiply to make 4 are 1 times 4 and 2 times 2. This is going to be the one that gets me to 3. To multiply to make a negative, I need a negative times a positive. So I need the positive one needs to be the bigger one because it needs to add to be a positive. So positive 4 and negative 1. These multiply to make negative 4 and they add to be 3. So x minus 1 times x plus 4. This is factored form. So what does it tell us? Well, it tells us the x-intercepts. The x-intercepts is where on the graph is the y value equal to 0. And the y value will equal 0 when either one of these factors is equal to 0. And so one of the x-intercepts will be when x is 1. When x is 1, y will be 0. And we could just put that on the graph. When x is 1, y is 0. And when x is negative 4, y is 0. So when x is negative 4, the y will be 0 because when I put in negative 4 plus 4 will be 0. Now, we can also find the axis of symmetry because the x-intercepts are the same height. And so the axis of symmetry has to be exactly in between them. And the easiest way to find it is to add these two numbers together and divide by 2. So we do 1 plus negative 4 and divide it by 2. That's the average. That's how you find what's exactly in between them. It's negative 3/2, which is negative 1.5. So the axis of symmetry is going to be x equals negative 1.5. So negative 1, negative 1.5. And we draw the axis of symmetry with a dotted line. And you can see how adding these two x's together and dividing by 2 will tell you halfway in between them is x equals negative 1.5. And what's useful about this is where the vertex is. The vertex is always where it's symmetric. And so the vertex will be somewhere on this axis of symmetry. So how do we find the vertex? What we can do is we can just put in the x value in for x And we could do it either at the beginning, or we can do it in either one of these forms. Both will give us out the same y values. Here, I think I'm going to put it in right here. So what I'm doing is I'm plugging in x. I know the vertex will come at x when x is negative 1.5. I just don't know what the y value is. And so to find the y value, I'm going to use this equation. Remember, this equation tells me for each x, what is the y? So when x is negative 1.5, I'm going to plug in negative 1.5 for x. I'm sorry, that got messy. I put in negative 1.5 here and here, and I'm going to simplify. 2 times negative 2.5 times positive 2.5. 2 times negative 2.5 is negative 5 times 2.5. When you multiply, there's no distributing. You only multiply if there was like a plus in between here. When you have three things multiplying, A times B times C, you multiply two of them together, get the answer, and then multiply it times C. So I multiplied these two together to get negative 5. Negative 5 times 2.5 is negative 12.5. And so the vertex will be at negative 1.5, negative 12.5. So that is a nice thing to know, and we can use it to graph it, although it's not quite as easy as it could be if we had it in vertex form. Try this one on your own. How do we get it into factored form? Well, hopefully you know how to factor. This one's just a equals 1. There is no common factor. So we're just looking for what multiplies to make negative 8. That adds to be negative 2. And so that's negative 4 and positive 2. A negative 4 times 2 is negative 8. And negative 4 plus 2 is negative 2. The bigger one needs to be negative so that they add up to be a negative. X minus 4 times x plus 2. And so what are the x-intercepts? What are the 2 points? Remember to write it as a point. So one of them is when x is 4, y is 0. And one of them is when x is negative 2, y is 0. These are the x-intercepts. Okay? Knowing the x-intercepts will tell us a lot of stuff about the graph. If we wanted to find the vertex, we could. How can we find what's halfway in between these? Remember, go ahead and find it. Where is at what x value will the axis of symmetry be? What x value will be the axis of symmetry? Well, hopefully we remember that we can just add these two x values together and average them. So 4 plus negative 2 divided by 2. 4 plus negative 2 is positive 2. 2 divided by 2 is 1. And so the axis of symmetry happens when x equals 1. We add the two x values that the x-intercepts are at, and we divide them by 2 to find what's halfway in between them. Hopefully we feel good about finding the midpoint from geometry. So the axis of symmetry is at x equals 1, and you can see that's halfway in between them. So how do we use that to find the vertex? Where is the vertex? I know the vertex has to be along the axis of symmetry, but what's the y value? Well, what is the y value? So I know the axis of symmetry is going to be at 1 comma something. What is that y value? And hopefully you know you can just plug in 1 into x here. So y equals, I'm going to plug in 1 for x, 1 minus 4 times 1 plus 2. That's what an equation does, is it tells you for each x, when x is 1, what is y? So y will be negative 3 times 3. Negative 3 times 3 is negative 9. So the y value will be at 1, negative 9. The vertex is at 1, negative 9. And that's what that quadratic looks like. Okay. I also could have plugged the 1 into here. I just want to show you this one time, then we'll be done. I could have plugged in 1 here. Y equals 1 squared minus 2 times 1. Well, you guys can't see that. I'm plugging in 1 here. 1 squared minus 2 times 1 minus 8. 1 squared is 1 minus 2 minus 8. 1 minus 2 is negative 1. Negative 1 minus 8 is negative 9. And it gets me the same y value. So again, the big idea here is we can get from vertex form to general form by doing order of operations. We square a binomial using that new squaring a binomial trick we learned. We can then multiply out whatever the a value was and combine like terms and get it in general form. We can get from general form to factored form by factoring. And factoring will tell us where the x-intercepts are, where the line crosses y equals 0. And halfway in between there will be the axis of symmetry. We do that by adding them and dividing by 2. And along the axis of symmetry, the vertex has to be. And so we can take the x value from the axis of symmetry and plug it in for x to find where the vertex is. All right, guys, hopefully you're feeling good about this. Practice it for just a minute and have a great day. Bye.